Now let's have a look at how we can work with collisions. So for that, I'm gonna start by disabling this pop kill because we really want the particles to be able to move freely without being killed. Right now they're just going to be dying because of the lifespan that I set here, so I'm just going to increase this to 10 and with a life variance of 0.0. Now, one of the most common things that whenever we need things to collide is the ground. We usually want to have the particles collide with the ground or something like that. So what we're going to do is create a ground plane. There's also an operator just for that, so we have a ground plane. So it generates an infinite surface. This is just a representation of that infinite surface. I'm gonna turn off the display proxy geometry. Don't really need to see that. Let's keep the grid. And the other thing we're gonna do is merge this obstacle into our simulation. So we'll create a merge. And here on the merge, you need to be careful because it is really important the order in which you merge these things. So we'll connect the ground plane first and then the gravity, and this is what's going to be coming out. And if you notice here on the merge, the relationship will be a collide relationship, and it's going to be the left input that affects the right input. Okay, so whatever comes from the left is going to affect what comes from the right. Okay, now if we simulate, you'll see that our particles bounce off from the ground. So here on the physical tab of the pop object is where you're going to be controlling the amount of energy conservation that you'll have once your particles hit the ground. Right now, they're going to be hitting the ground. I'm going to increase the gravity back to its regular value of minus 9.8 meters per second squared. And we'll have a combination of these physical parameters and your colliding object physical parameters. If you notice here on the ground plane, we also have a physical attribute. And if right now we have 0.5 on this one, and we have 1 of bounce on this one, let's make everything at 1. And what we should see is that the particles bounce pretty much the same amount as they bounce back exactly the same amount. There's no loss of energy on the impact. The other thing we can take into consideration are things like friction, and the friction is gonna just say, so here on the ground plane we have friction at 1, and that's also gonna be kind of affecting the way things bounce. Okay. So without friction, the particles will just slide over the surfaces. If you add friction to this, let's put this at 1 and put the friction here at 1, you'll see that the particles don't slide as much. They pretty much stay in place. So now with these parameters, we get this effect. So I have a bounce of 0.5 on the ground and a bounce of 0.5 on the particles themselves, and I have a friction of 0.2 on the particles, and the ground has a friction of 1. So these are the default values for the ground plane. So usually I'll just work mostly on the pop object itself. When working with collision, there are a few attributes that are coming out of that calculation, and we can have access to those. If we look at this now and we go to our pop object and we check in our geometry what we have here, we should see that we have, let's go all the way up to here. Right now we don't have any particular attributes being generated from the collision. But if you go to your pop solver and you go to the collision behavior and you add hit attributes to your simulation, you'll see that whenever there's a hit, your particles should now have a few hit attributes: hit normals, hit num, hit path, hit position, and a lot of attributes that are being generated just because of as a consequence of actually calculating collision. So this is probably the simplest situation where you're just colliding with the ground. Let's see how things work when you're actually colliding with different objects.